So yesterday we worked through linear inequalities. Today we're going to work through nonlinear inequalities because Rhiannon loves them so much. She's going to give out shout out to YouTube Nation.
Hi YouTube Nation, it's Rhiannon Farr. You can follow me on Twitter at Rhiannon_Farr if you need math help. Thanks, bye.
All right, we love that. Great, way to go. So we've got let's see, nonlinear. Nonlinear means what? What is linear? Straight line. So it'd be x to what power? First power, very good. So we got x of first power. This is nonlinear. Nonlinear means that we have a degree different than 1. Okay? Degree different than 1. So I'm going to show you two ways to solve this type of inequality. We're going to show one, which is a number line approach. And then second of all, we are going to show a graphical approach. And the first thing we do is we have to zero out the inequalities. So we have x squared plus 2x minus 15 is greater than 0. And the next step is that we factor. What does this factor to? So what are our two solutions? -5 and 3, right? Now, here's what a lot of people do at this stage of the game. You're going to get to the test, and you're going to start doing voodoo mathematics. And it's going to seem to be familiar to you, and you'll even be able to justify it in your brain, but you must resist the temptation. I'm going to write it down. Don't you dare write it down. X plus 5 is greater than 0, and x minus 3 is greater than 0. So x is greater than -5, and x is greater than 3. That's my solution set. That is entirely illegal, and I'll give you an example why. Would you agree, by looking at this, that 0 would be part of the solution set? Because 0 is greater than -5. So then plug it in. 0 plus 0 minus 15. Is that greater than 0? No, it doesn't work like that. So therefore, we must do something else. And I'm going to show you two ways. Number one is the number line test. And again, your key is that you see that it's not linear. So you can't solve it like that. Must be a little bit more careful. And you'll understand after I show you the two examples, -5 and +3. The reason why I plot -5 and +3 is those are special numbers. If I were to plug those back into the inequality, what would you get? You would get 0. So something interesting happens at 0. It changes value. Okay, so let's see what values it changes to. We're going to plug in a number to the left of -5. What's the number to the left of -5? -6. You can plug in -7, -8. You can plug in anything as long as it's to the left of -5. If I plug in -5 here, what do I get? I'm sorry, if I plug in -6 here, what do I get? A negative. If I plug in -6 here, I get a negative. So I will get a negative times a negative, which is a... So all of these numbers will produce a positive result. What is the number between -5 and 3? 0. If you were to plug in 0, 0 plus 5 is a positive, and 0 minus 3 is a positive times a negative will give you a... So we have that. And then your last value, we can plug in 4, 5, 6. Whatever you plug in, you'll get a positive times a positive. And positive times a positive will give you positive. Now, we'll talk about the parabola in a second, but before we look at the graphical approach, let's examine this, because you will have to use the number line test in order to do other ones. So the question is, are we wondering where this is positive, or are we wondering where it's negative? Well, look at the solution. It says we're wondering where this is greater than 0. What does it mean to be greater than 0? It means to be positive. So the solution set to this inequality is wherever you get positive results. I get positive results here, and I get positive results here. So I'll express the answer in interval notation from -infinity to -5, union with 3 to infinity. Again, I showed you the example why it doesn't simply work to set both greater than 0 and solve. Some people may say, well, just flip one. Well, how do you know which one to flip? Okay, you're just going to say, well, I know it's a disjunction. After a while, you end up thinking a lot of things through, and it doesn't necessarily always work out. So just trust this approach. If you do end up with a quadratic, it's also a great approach to use a graphical approach. Namely, I will factor it, again, to x plus 5 times x minus 3 is greater than 0. Now, if I were to look at a graph, what shape does that make? Makes a parabola. And the parabola travels through -5 and +3. Is this a parabola that is right side up or upside down? Why? I would say about 1 out of 3 people make a mistake here when they're analyzing this. Look at the two things we're thinking about. Number one, we've talked about greater than 0. This does not have anything to do with the shape of the parabola. Rather, the number in front of the x squared determines the shape of the parabola. So forget about this when you're viewing the shape. Always look at the value out front. It is a parabola that goes right side up. So now we have to think about it a little bit differently. It says that it's greater than 0. What does it mean to be greater than 0 graphically? When x is above, or when the graph is above the x-axis. So you can see that I am above here, I'm above here, I'm below here. So in order to answer this question, I will look at where I am above, and I am above from -infinity to -5, union with 3 to infinity. Same solution, correct? I think that the graphical approach is faster. If you know what the graph looks like, use the graphical approach. If you don't know what the graph looks like, use the number line approach. We'll do an example where I show you both methods here. We will first try a graphical approach. This factors to what? X plus 4, x minus 2. At what points will it cross the x-axis? -4, +2. Does this parabola go right side up or upside down? Right side up. You can see from my graph that I've generated, I have a positive, positive, negative, negative, positive, positive. Are we wondering where it's positive or where it's negative? We're wondering where it's negative. Why? Because it says, where is it less than 0? So therefore, I'm looking between -4 and +2. That's it. Yes. No, it wasn't a dumb question. There are no dumb questions. Actually, I did encounter a question one time that all right, here we go. You know what I don't like about this next problem? Right, I don't like negative. So since it's a free country, I get rid of it. And when I get rid of it, switch the sign. Yeah, baby. Isn't that awesome? So let's do a number line test approach here so you can understand that. Does this factor? Sweet. Make my number line. Got 1 and 5 halves, which is 2.5, right? Let's test some numbers. What do you want to test? 0, awesome number. Again, negative times negative is a positive. Now we can plug in 2. I get a negative times a positive is a negative. And I plug in 3, and I get a positive times a positive is a positive. You see, here's what I've done. I've always made it so my parabolas go up if I simply just multiply through by a negative, right? Second of all, if I know the parabolas go up, you might say they'll always be plus, minus, plus, correct? That is not correct, because suppose you had this, x squared plus 1. Does that ever cross the x-axis? It never does. Or suppose you have negative x squared plus 1. I'm sorry, negative x squared minus 1. You're like, well, I'll multiply through by a negative. Well, when you do that, you factor out the negative, and you then get the x squared plus 1. And again, it still doesn't cross. So the fact is you got to be careful. So we've seen examples where this works out. I wonder where this is positive or negative. Positive due to my last piece of work, negative infinity to 1. Thank you, Justine. I use a bracket. Union with bracket 5 halves to infinity. Why the bracket? Because it's equal to. Carter. Because sometimes people will look at the problem, they'll say, I'm too smart for this, and I'm just going to write positive, positive every time. And the fact is, you can't do that. Don't do that, because you might have some changes. Now, flip it over. Yes, this is more difficult, but I revised the lesson for this year, and I will say that this went better than it has any other year. You guys will be great at this. So the question is, do you know what that graph looks like? There will be a time this year I'll teach you what that graph looks like. You'll be excellent at doing it. You'll be quick at doing it. But right now, you don't know what that looks like, do you? And so if you don't know what it looks like, you can't use a graphical approach. You must use a number line test. And so this is already factored for me. So I find the zeros, which are 2, 4, and negative 3. Then I make a number line. And on that number line, I place my zeros in the order that they fall on the number line. And this is where I use a graphic organizer, okay? I start to make a table. And I like my way of doing this. I make a table. A table has columns and has rows. The number of columns will be the same as the number of factors plus 1. So how many columns will I have here? Watch how easily I make them. As I divide it with the numbers, I now have 4 columns. My number of rows is the same as the factors, so how many will I have? 3. I put the factors over here, x minus 2, x minus 4, x plus 3. So we're going to do the same thing that we did before. This is just a way for us to help organize our information so we're much less likely to make a mistake. I still have my number line. I'm just going to gather my information below. So I'm going to test a number to the left of negative 3. What would you like to test? Negative 4. So I'll place it into each of these. Negative 4 minus 2. Negative. Negative 4 minus 4. Negative. Negative 4 plus 3. So I got all negative results there. Now we move on to the next interval, number between negative 3 and 2. 0. Negative, negative, positive. Now I move to a number between 2 and 4. 3 minus 2 is positive, negative, positive. And finally, to the right of 4, positive, positive, positive. Now look at what we're doing, folks, so we don't lose sight of our goal. We would be taking whatever result is here and multiply it by that result and divide it by that result. So in other words, do 3 negatives make a positive or a negative? They make a negative. Do 2 negatives make a positive or a negative? Positive, negative, positive. So now I can use that to determine what my result actually looks like. Are we wondering where this whole thing is negative or where it is positive? Because less than 0, we're wondering where it is negative. And so you can see that we are looking from -3 on this way. We're looking from 2 on to 4. So I will express the answer now in interval notation. The answer will be from -infinity to -3 union with 2 to 4. Kind of a little bit trickier, huh? That's the same way that the other hours felt. When we walk through D, I think you're going to feel better, and then we'll be able to try 2 more realistic problems that you'll be seeing on your homework. So we're still taking baby steps. Let's take a little bit bigger step right now. What don't I like with this problem? So I get rid of the negative, and I change the sign, just like that. How many factors? 4. Why is it 4 and not 3? There's a 0, so you got 0, 5, -2, and looks like a 10/3 or 3.3 repeating. So I will make my number line, and on that number line, I'll place all 4 values, starting with -2, then 0. Oh, I don't know why I did that. I usually like to put them up here. So how many columns will I have? 5. The number of factors plus 4, so I'll have 5 columns. The way I like to make my columns is I just drop this down right over here, and I just drop my lines from my solutions. How many rows? On the outside, I put the factors 3x, x minus 5, x plus 2, and 3x minus 10. What would you like to plug in? -3? -3 times 3 is negative. -3 minus 5, negative. -3 plus 2, negative. This will be negative. Sweet. You know what? What's that? Last one? That's okay. I made the same mistake earlier. -1 times 3 would be a negative. A negative. Now I've got a positive, right? Then a negative. What number would you like to plug in between 0 and 10/3? Okay. You know, it's interesting numbers people choose. I choose 1. That's what I would choose right away. But we can choose 3. So positive, negative, positive, negative. How about between 10/3 and 5? 4, positive, negative, positive, positive. And how about plug in 6? We'll get positive all the way down. So, do positives at all affect the outcome? We're only concerned about the number of negatives, right? So we get a positive, a negative, a positive, a negative. Again, you might look at it and say, will it always change? It will always switch from one to the other? Not all the time. Most of the time it will, but not all the time. Are we wondering where this is positive or where it's negative? Where it is negative due to this sign, which we created up there by factoring out the negative. Very good. There is a little trick here. We'll see if anybody can catch up on it. See what we can do with this. I have a -2, I have a 0, I have 10/3, I have 5. Parentheses or brackets. This is incorrect. Anybody see why? Anybody see it? No? No? What? Can't equal what? It can equal 0. What can it equal? Look at your original. It can't be -2 or 10/3 because that would give you 0 in the denominator, right? So this is the last little hiccup for the problem. As you look at it, you do have a bracket on 0, but you have a parenthesis on -2. Now, if you did that on the test, I would take off just a half a point. But we cannot include 10/3 or -2 because that is not part of the domain of the function. You would get 0 in the denominator. Makes you angry inside, huh? Lauren's ready to scream. Scream, Lauren. Just. Okay. Wow. So much for the star quality of kindness. Did you eat a bowl of grumpy for breakfast? Okay, no, I can't. Okay, here we go. So as we start out, and you don't have to flip back to this page, but really the step is this. Every time you do these problems, you always have to start by gathering everything to one side. And then you need to factor stuff out, make your interval, make your table, and solve. Now, I haven't shown you anything yet where you have to gather and factor, so let's do that right now. Let's take this 4x plus 2x, or 4x over 2x plus 3, and let's gather the 2 over to the other side. I can't factor that as it sits right now in a meaningful way. First, I need to create common denominators. In order to create common denominators, I'll multiply top and bottom by 2x plus 3. So my new inequality will read 4x minus 2 times the quantity, 2x plus 3, all over 2x plus 3 is greater than or equal to 0. Let's simplify it. What will happen? -6 on top. So you have a -4x and a 4x will make 0. Then when you distribute the -2 to the 3, you will get a -6 over 2x plus 3 is greater than or equal to 0. Guess what I don't like? The negative, so I get rid of it. Now, let's look at the top. Is 6 ever equal to 0? No, so you just leave it alone. Is the bottom ever equal to 0? Yes, it is. At what spot? -3 halves. Subtract 3, divide by the 2. Oh, what? I'm sorry, I thought there was a question. Okay, all right. So how many factors do I have? 1. So how many columns will I have? 2. How many rows will I have? 1, which is just 2x plus 3. What should we plug in? And I get a negative. Plug in 0 and I get a positive. We have a negative and a positive. Are we wondering where this is negative, or are we wondering where it's positive? Where it's negative. So we go from negative infinity to what? You get 3 halves, parenthesis or bracket. The equality means bracket. However, because I would get 0 in the denominator, I must eliminate that bracket and use a parenthesis. If you would take this -3 halves and plug it back in, you would get -3 plus 3, which is 0, and you cannot have 0 in the denominator. So you may not include that as part of the solution set because you can't plug it back in. Last example, folks. You are doing excellent. You are hanging in there. Just note that this is a new skill. And when we get these new types of skills, like tomorrow, you'll have a nice work day to work through these type of problems. You have fun. We will miss you. X over x plus 1 minus 3x over 1 is less than 0. You tell me what to do. Yep, and then create my common denominators. Negative 3x times x. Negative 3x times 1 is a negative 3x, and a positive x makes Guess what I don't like? Make sure I flip the sign when I take that negative out. Factor out an x. Now what? Do the line. I did the line, now what? What do I plot first? How many columns? How many rows? First number to test. -2. I will get a negative, negative, and a negative. Oh boy. What about the next one? Yeah, a lot of people go straight for a fraction like -5/6. They're like, yep, that's where I want to be. I don't like it. I would rather just plug and say -0.9. See you later, buddy. So I think that plugging in a decimal is actually easier than plugging in a fraction. I mean, they're both numbers, right? So I like to plug in a -0.9. So that will give me a negative. What is 3 times -0.9? -2.7 plus 2 will still give me a negative. And then -0.9 plus 1 is positive. And then again, I think -0.1 is an easy decimal to plug in this situation. It'll give me a negative. -0.3 plus 2. -0.1 plus 1 will still be a positive as well. I can plug in 1 and I get positive, 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 positive. 3 negatives make a negative. So you can see my set here. Am I wondering where this is positive or where it's negative? Wondering where it's positive. It is positive here, and it's positive here. So therefore, my solution set, do I have to worry about any brackets? Why do I not have to worry about brackets? There's no equal sign. So -1 to -2/3. union with 0 to infinity. Can be confusing. Tomorrow's your chance to work through that. Raise your hand if you have a test tomorrow in another class. I totally get it if you need to show up and start studying for that test, but at the same time, I also know that this day will be given to you to really shore up those questions. So if you have questions on this stuff, then we got to find another time. Also, this assignment, it is going to take you a little while. I would encourage you to try to at least get through these tonight. These are quadratic. For those of you who are math purists and you say to yourself, there must be an easier way to do those types of problems. That's how I reacted when I first saw them. The easiest way to do the problems is to be able to sketch the graph. But if you don't know what the graph looks like, then you're left to interval testing. Now, there are quicker numerical methods and trial and error to get through it, but the basic setup is kind of what you do. It is my opinion that the last two questions we did, that a question like that would be your hardest question on the next test. So if you can get through that, you have an excellent shot at getting an A on the next test because you are super intelligent and you're ready to go. All right, I'm going to